Alright, in this example, it tells us to determine whether each is a factor. So determine is a yes or no question. And they give us a polynomial function, and then they give us a binomial. So we just learned about the factor theorem is that if I basically either use long division, synthetic division, or the remainder theorem, and if it's equal to 0, then it's going to be a factor. And if it's not equal to 0, then it's not going to be a factor. So here, my first binomial, a big idea for this chapter is the binomial x minus 1 is the same thing as x equals 1. Well, what do I do with this x equals 1? I'm going to put it into my function here. So I'm going to put it in for every x value. Let's go ahead and do that. F of 1 equals 2 times 1 cubed minus 1 squared plus 2 times 1 minus 3. Zoom in for you. So basically all I did was I put in x equals 1 for every x value. And then we're just going to simplify. Class 1 cubed times 2. 1 squared. Opposite of that. 2 times 1. Positive 2. And then minus 3. Class 2 minus 1. 1 plus 2. 3 minus 3 is 0. Ooh, this is good. This is good. Because it's set equal to 0, then it is a factor. So yes, it is. Yes, it is a factor. Let's try that next example. If my binomial is x plus 2 class, then your x is equal to? X is equal to negative 2. Class, what do I do with that number? Plug it in for every x value. There's an x, there's an x, there's an x, there's an x. Let's plug it in. I have f of negative 2 equals 2 times negative 2 cubed minus negative 2 squared plus 2 times negative 2 minus 3. And then here we're just going to simplify. Negative 2 cubed. What did you say, Ducky? Negative 2 cubed. Negative 8. Negative 2 squared. 2 times negative 2. Negative 4, and then minus 3. And then we'll just clean that up. 2 times negative 8. That becomes negative 4, negative 4, and negative 3. They're all negatives, right? So 20, 24, and 27. So when I put in negative 2, it equals negative 27. Class, is this equal to 0? It's not equal to 0, therefore it's no, not a factor. Okay, so when I put in x equals negative 2, because it's not equal to 0, according to the factor theorem, it is not a factor.